are busy with probabilities and we've got probability rules. Lots and lots of rules. We do have the identity that's the most important of them all, but you can't say the one is more important than the other, otherwise the sums won't work out. Right, so the first question starts off and says, if A and B are mutually exclusive events, what does that immediately tell me that you should know? But it doesn't intersect. So the AND part is 0. Now the AND part can be said AND, or you can say intersection. Are you with me? The OR part can either be or union, like always. So I can put either one of that in a question paper. So mutually exclusive means there's no intersection. The AND part is 0. Further, they gave me that probability of A was something. They gave me that the OR was something, and that they asked me for was not B. What's the probability of not B? Well, I can easily go for my formula, which is A or B, the identity for probability. The OR is equal to PA plus PB minus PA. Okay, now this one you already know is 0. And that was the whole catch of the sum. Otherwise, there wasn't enough information. If you didn't realize mutually exclusive means that this is 0. Little bit of another problem. The OR part was 0,5. The A part was 0,2. And they're asking me for? Oh, but I'm going to find B. And then I can find B. Alright. So for PB, it would be 0,5 minus 0,2, which is 0,3. And if the probability of B is 0,3, then the probability of not B will be 0,7. Because B and not B are what events? Complementary. They add up to 1. It's either the one or the other one. That's all that can happen. So they add up to 1. So if I have the one, the other one is 1 minus 0,3, which is 0,7. Well, how many marks for such a sum? 4. About 4. Because I'm definitely testing whether you know that the AND part is 0. And testing the identity, the probability identity. And then after finding B, to find not B. That's also worth a mark. Alright, then I gave you one that says something about exhaustive events. What must you know? What is the knowledge that you must have about exhaustive events? There's no? That the OR is 1. So if you're thinking Venn diagrams, it's only inside of those Venn diagrams. Can they intersect? No. Yes. But the OR part is everything. There's nothing, in other words, swimming around here at the edges. So the OR part, P, A, or B, is equal to 1. And that's all that they said was exhaustive events, and you had to know that. If you don't know that, then you're missing what I'm testing. Then they give me that the probability of A and the probability of B is the same. And they tell me that the AND part is equal to 0,1. And they're asking me to find X. How would I find it? With the identity. And the identity says, again, OR is equal to probability of A B minus and B, which you can write on any way you like. But now they did tell me that the OR part, oh, they didn't really tell me, did they? If you didn't know that, you've lost this mark. The PA and the PB were both X. And the AND part was 0,1. It was given to me. And therefore I can go and find out what my X is, because I can add the like terms together. This will become plus 0,1, and that's 1,1. If this was the answer, I was very worried, because the probability can't be more than 1. But that's not the probability, that's 2x. That means that x is going to be 0,5. Half of that. If ever you do a probability somewhere, it can't be more than 1. Can't be negative either. So if you're doing it and something like that happens, you made a mistake somewhere. You know that your probability can only be from 0 to 1. 0% to 100%. Okay. Next question, and that was a question, right? That's it. Find x, done. How many marks? Definitely for the or part, for doing the whole identity is a mark. Substitution in and finding your x. Find x, I found x, I'm done. Let's, for interesting sake, say what would this Venn diagram look like? Is it going to intersect for this A and this B? How come? Okay, so if I ask you a question like this, are A and B mutually exclusive? What would you say? No, they are not. Reason?
They intersect.
They intersect because the and part is not
Zero.
zero. Are you with me?
Yes,
Can you
ma'am.
hear I'm keeping repeating some questions? That's the ones that they ask. So that intersection is 0, 1. A was 0, 55. B was 0, 55. And I'm not putting it in there because it includes the intersection. So then if the whole of A probability is 0, 55, the intersection is 0, 1, that leaves me with 0, 45 here, and the same thing's going to happen on that side. And do you see that they are exhausted? When I add the or, meaning both of those circles and the intersection, I'm adding up to 1. So there shouldn't be anything outside here when they are exhausted. Are you with me? You have to do that, but it makes sense when you look at it like that. Okay, next question I'm testing, complementary. What does it mean if they are complementary? Well done, you look very nice. Complementary. Okay, it means that the probability of A is equal to the probability of B. Is that right? No? When you add them, you get 1. The only other thing that you've got is that PA is equal to 3 times the probability of B. So let's say, let PA be equal to X, then this will be equal to 3X, right? Where am I going with this? If I go to my, say, can I do the identity again? Or can I just go here? Because this is what I'm actually testing, that you know that the two added together is 1. Go to the identity, then you're stuck and you say, oh, what's the or, what's the what? I'm sure that there's another way, there's always an alternative. But if this is my equation, I can substitute A with X, then B would be 3X for a reason. They told me that the one was 3 times as likely as the other one. Probability of A is a third of the likeliness of PB. Are you with me here?
Yes.
So that means that 4x is equal to a 1 and x is equal to a quarter. Now can I leave it as a quarter? Yeah, normally if we go for this sum for instance and everything was given into decimals, then rather leave all your answers in decimals as well, but nobody's going to subtract marks if you'd rather go for normal fractions instead of decimal fractions. This one had no decimals whatsoever, so if you want to leave it in normal fraction or 0.25 as a decimal or even 25%, I'm happy. What was the question here? I don't know. What was Jay's question? Find PA and PB. So PA is 0.25. Now why would I change that in the middle of a sum? See how frustrated teachers get. Who cares if you changed it or didn't change it? And that would mean that PB
is 3 times.
Are you with me here? Because the probability of B is 3 times as much. Is that 3 times as much?
Yes.
Do you understand what's going on there?
Yes.
And do they add up to 1, making them complementary?
Yes, ma'am.
Right. Oops, let's just change this and correct it. This answer is swapped around. You should have said, if the probability of A is 3 times the probability of B, that means if I take probability of B as, for instance, X, then 3 times X would be, remember this is an equation. So I'm stating that probability of B should be X. Then the probability of A is Think about it. The probability of A is 3 times as much as the probability of B. Do you see that the probability of A is 3 times as much as that one?
Yes.
Now this child, ma'am, would have lost 2 marks here. Because the essential of the original equation was right, although I could clearly see that you put the wrong stuff on the wrong places. It should have been PA is 3x and PB is x, which still gets into that answer, but ma'am, the answer is still right. No, it's not. This is swapped around because then x was the value for PB. So PB was a quarter and PA was 3 times that, which is, they still add up to 1 because they're still complementary, but this was an essential mistake that I made. Whenever I say K is twice M, which one is the larger?
K.
K is the larger one. Whatever M is, you've got to double it to get to
K.
K. Are you with me with my mistake here?
Yes.
Common error. Common error. Even more rules. There are events that aren't only mutually exclusive, aren't only complementary, aren't only exhaustive, but there are events that we call independent. Classic example of being independent events is, let's toss a coin and let's throw a dice. Do you think they've got anything to do with each other?
No.
So do you think that would be kind of like instant to say that they are independent of each other? The fact that the coin falls on heads or tails has got nothing to do with the fact that my dice gets rolled to a 5 or whatever. Independent events. Makes sense, the word?
Yes, ma'am.
But now there's rules. And the rule says if they are independent, only if they are independent, then the intersection part, the and will be when you time the 2 probabilities. New rule. New rule. It makes more sense when you get to the tree diagrams, which we're still going to be doing, where you actually time all of your branches in your tree diagram. When you get there, you'll understand what I'm saying now. But if the question then says to me, a person is chosen at random from a population, let A be the event that a person's birthday is in August. Let A be the event that a person's birthday is in August. Then what's the probability of A? Yes, excuse me? 1 over 12. How do you know that? Because you know that there are 12 months in a year. Person is chosen at random. What's the chances that this person is born in August? Also, let B be the event that this random person that I chose is male.
1 over 2.
Aha, how come?
Because there's
Male,
2
female. Are you
choices.
with me? There's 2 choices. Yeah, I said it. Okay, so if we say and, if these are equal to each other, then these are independent. So I'm saying, the question asks, determine the probability that the person chosen will be born in August and he is male. So if he is born in August and male, can I do what I said there?
Yes.
Is the fact that I choose somebody here from the quad and is a male or a female and born in August, is those 2 things independent?
Yeah.
Yes, they are independent. So if they are independent, then I've got to take them and I've got to
Times them.
times them with each other. So the probability of being male and being born in August is, A was 12 times up. Now you just have to write all of that down. If the question was just male and born in August and you said probability for male is, probability for born in August is, and your answer would be 1 over 20. 4. That's the probability, but only if they are independent. Last example said, if I give you PA, see, the moment at the start of PA is, PB is, PO is, PO, then you're thinking that formula,
Yeah.
that identity, right? Yes. But now they also say that they are independent. So if they are independent, what is the new rule that must come to mind?
P and P.
The and must be multiplying the PA and the PB. Immediately when it's independent, you multiply. How does that help me? Think about the formula. That's your formula. You have the A, you have the B, you have the OR. But they are asking me to go, no, sorry, they don't have the OR. I'm trying to find the OR. So this is what I'm looking for, and these were the two I had. So where does this come from? From doing the sum. The and sum, you should go do yourself. Once you find it, you can fill it in there. Meaning you've got 0, 6 times 0, 5 on a calculator, because you should actually know how to do 0, 6 times 0, 5 with your own brain. 6 times 5 is 30, and there should be 2 after the bracket. Okay, calculator is wonderful. So the and part then should be 0, 3. If you didn't do that, because you didn't know what independent was, you didn't have enough information. Okay, so independent is that product rule that you've got to be able to go apply. Probability of A was 0, 6, probability of B was 0, 5, and the total answer for the question, the OR part, was 0, 8. Done and dusted. But you see how they mix them up. You don't know what mutually exclusive, exhaustive, complementary, independent are, so it's a stack of all the list of things that you must know. Right.